The information presented is for informational purposes only. The opinions expressed are not necessarily the opinions of any Daikin company. This information should not be confused for accounting, legal, medical, or other professional advice. Please seek advice from a qualified professional for any specific questions.
It's actually a very safe refrigerant.
Daikin wants to be involved in the community.
Making another touch point to build my brand.
So the first question we ask everyone is, welcome to the Accelerated HVAC Success program. My name is Ben Middleton. I'm the National Sales Training Manager for the Goodman, Amana, and Daikin brands. Today we are on Sargent Beach on the Gulf Coast of Texas. I've got my good friend here, Clifton Beck. He is the Director of Digital Media over at ESCO. Clifton, thank you so much for joining us.
Absolutely, glad to be here.
So, Clifton, we've got all of these balloons here.
Yeah, a little crazy.
I asked you to come in and we were going to talk about refrigerant. I'm not sure what all of these balloons have, but I'm looking at here. It looks like I've got some chemicals that are marked out on each of these different balloons. So I've got my green balloons. These are chlorine.
Yes.
We've got blue balloons. These are
going to be our fluorine.
Fluorine. And we got a black balloon.
That's going to be our carbon.
Okay, and then there's some yellow balloons that are floating around as well.
There are. We got a variety of different atoms. We're going to go through a basic chemistry lesson, okay?
All right.
This is something that I've learned over the last couple of years, diving a little bit deeper into refrigerants. I spent my career in commercial refrigeration, so I've seen a lot of refrigerant transitions, and I never really understood what refrigerants really were. So we're going to do a deep dive into refrigerants, and it's absolutely ideal that we're sitting next to some water, R718, right? So most chemicals act as a refrigerant. They have a boiling point at which they turn into a vapor when they rise with heat, and then they cool back down into liquid at that same point. Refrigerants are the same way. And so let's start with a fundamental element called ethane. Okay? Or methane, right? They're just different versions with carbon-based. If we look at methane in particular, methane is a base that has a single carbon with 4 hydrogens to it. Well, when we start producing refrigerants, we're just replacing different atoms within that structure. So we're going to start with a fundamental refrigerant that many people know, and I'm going to show you how we transition into current refrigerants. So if I were to start with 2-chlorine, right? So we had 1 carbon, the black one. We had 2 chlorines, the green, and 2 blue, which are the fluorines. So that is 2-chloro, so dichloro, 2 fluorines, difluoro, and it has that methane composition. That's dichloro-difluoromethane, otherwise known as CFC-R12.
Okay.
That's our early foundation, R12, right? So if we had that was a A1 classified refrigerant, but the chlorine was the contributor to ozone depletion. The first step that we took in doing that was we removed 1 chlorine.
All right, so I take 1 away.
Right, now we got to stay with our methane molecule, so we're going to have to introduce 1 yellow into our mix here, right? So now we're back into our methane where we have our carbon base. We have now 2 fluorine, 1 chlorine, and 1 hydrogen. Well, the hydrogen is part of that methane composition, that molecule. So now we have a single chlorine, right? Monochloro. We have 2 fluorine, difluoro, monochloro, difluoromethane.
All right.
Idea where we went here? C H F. It's an HCFCR 22. So that's how we got to R22.
All right.
Now, let's go one step further, okay? Let's take out that remaining chlorine, that ozone depletion factor.
I got rid of all
and
these.
let's get over to a place where we have now 2 hydrogen, 2 fluorine, and 1 carbon, right? So we are now in a difluoro. Our hydrogen was our methane, so it's just difluoromethane. That is an HFC-R32.
All right.
That's how we actually got from R12 to R22 to R32 in a single component molecule, right? So we actually came up with R32 back in the 90s. It was a really good refrigerant. We weren't quite ready for the flammability of it. So the fluorines in there, those are actually flames, excuse me. Those fluorines in there are actually flame suppressants. These hydrogens are very flammable, right? So in the mix of that, we had a very slightly flammable refrigerant, although it was a very good refrigerant, but we weren't ready for it in the 1990s. So we actually introduced another refrigerant into that. We blended it, and we came up with a different chemical solution. We used a chemical compound.
Here, I'll hold that one for you.
Called R125. And if you see all of the fluorines in that, it was actually quite the flame suppressant.
Yeah, there's a lot of them.
There's a bunch. So we were able to blend R32 with R125, and then we came out with this HFC refrigerant that we called R410A.
Yes.
So this was actually the molecular composition of R410A. It was a blended refrigerant. All 400 series refrigerants are blends. So that was where we ended up. So we had some solutions in the residential, light commercial air conditioning sector. If we could get back to R32, right? Because we started going through this HFC phase down. We were looking at ways to reduce the global warming potential of our refrigerants. And when we introduced R125, it actually increased our global warming potential
All
pretty
these
significantly.
fluorines, right?
Yeah, it did. So it was actually higher than R22 that we had. So we were like, okay, so what are we going to do with this solution? Well, the first thing we could do was we could remove R125 from the solution. So we'll take out R125, but we're going to keep one component of it. Let's get rid of these here.
These ones?
The two blue with the yellow.
All right.
And we're going to bring in this one here. And this is a very unique little chemical. So let's put these two together. All right. Do we need to remove that other one for you?
We got it.
We got it over there. All right.
All right.
So in residential light commercial, we had R32 as a good solution, a little mildly flammable. That was a good one for us, right? We could have went to this in the 90s, but we weren't ready for that flammability. Now, again, remember, many industries are going through this HFC phase down. In the automotive industry, they were going through the same phase down, but they didn't have a blended refrigerant to do any construction with. They had a single component refrigerant called R134A, and they really didn't have a solution for a lower global warming potential refrigerant than that 134A. So they actually went back to a chemical that has a long history in our industry that a lot of people aren't aware of. In 1958, there was a chemical that was introduced that is a 2,3,3,3 tetrafluoropropene that has a olefin bond to it, and it was actually patented in 1960. But it was at that time, a mildly flammable gas. We weren't ready for that as a refrigerant, but move forward, we were able to re-look at that chemical and go, that's actually a really good refrigerant. And now that we are okay to re-look at some of these mildly flammable refrigerants, it's actually a really good replacement for 134A in the automotive industry.
Okay.
So around 2012, we started introducing what we now know as R1234YF or R1234YF or just simply YF to replace those 134A systems in automotive. And so the industry looked at the different options that we had, and there were manufacturers that looked at 32, and then they seen that the 1234YF was in the industry. So then they actually decided, well, we could blend the 1234YF with 32 and come out with other refrigerants. And so predominantly what we're seeing is the blend of R32 and R1234YF for chemicals like R454A, R454B, as well as R454C. All three of those blends are just different proportions of 32 and 1234YF. And so we will see different versions of this blended chemical being used for air conditioning applications as well as refrigeration. So in the air conditioning market, we're going to see our two products. We're going to see R32 that Daikin is using, and then we're going to see a blend of 32 and 1234YF that is R454B that will be used in other manufacturers. So we didn't end up with one refrigerant in the HVAC industry. We ended up with both of these, and they're very similar in operating pressures to R410A.
Yep.
But as you can see, they're all very different. Chemically, they're very different. They all three have R32 as their base, but they're not designed the same way to operate in systems. So if we have a R410A system, we can only use R410A. If we have an R32, we can only use R32. And if we have an R454B, we can only use that R454B. So understanding the chemical composition of us lets us see that whole progression to where we are and why we end up using the R1234YF. The interesting thing is I've even myself had to change the way I looked at refrigerants in this last few months because I always looked at R32 and R454B and R1234YF as being new refrigerants. Not the case at all. Technically, the only new refrigerant out of the bunch is R454B. R1234YF, remember, that was patented in 1960 as a chemical. It just wasn't ready for an industry as a refrigerant. And so R32 has been the backbone of our industry for decades, and going forward, it will still be a backbone of our industry.
Well, that's fascinating. And, you know, as I'm looking at this and I'm looking at what I'm holding here, what you've got there, I mean, there's a lot of molecules that are here.
Yeah, there's a lot of things going on. There's some unique things too.
Yeah.
If you notice, it's kind of hard to tell with the wind blowing, but between two of those carbon atoms, see those two little red bonds? That's actually an olefin bond. So most chemicals that we work with have a single bond between the atoms and the carbon base. Well, with an olefin, they've actually chemically separated that singular bond into two lightly structured bonds. So if this refrigerant is introduced into atmosphere, like through a leak in a system, it actually breaks down very quickly, which is why we have that lower GWP.
Okay. Well, this has been fascinating. I think it's helpful for a lot of contractors to take a look at all of this, all of these molecules and everything that's going on. I appreciate you bringing your toys to the beach and letting us play with them as we go through this. But you know, when I think about it, you know, a single component, there's obviously some advantages to a contractor utilizing a single component versus using, you know, the blended and having the two different molecules that are here, such as you don't have to worry about any glide.
Yeah, a lot of people don't think about glide. You know, we can actually step back and think about that R410A molecule that we built a little while ago that had a combination of R32 and R125. A lot of people don't realize there was glide in R410A, right? They are two different chemicals with two different boiling points, but they were very close to each other. But they absolutely had some glide, which is the reason when we went to R410A, we were instructed to turn the tanks upside down to charge with liquid only. It wasn't ever explained to me why we did that, and later it made sense. Well, we had two different chemicals, and we wanted to make sure we kept them in liquid form, because in the vapor, they could potentially separate if we had a leak, and they were very, very close in temperature to their boiling points.
Right.
So, yeah, in many ways, a single component refrigerant is easier to like calculate superheat and subcool, because when we start working with blended refrigerants, we have to take into effect that glide, that difference in our boiling points. And with like today's digital gauges, most of those are going to calculate that for us. But if we're using a blended refrigerant, any blended 400 series refrigerant, we have to make sure that we're looking at the boiling points and understanding the difference in that, and that we don't start calculating subcooling until we are below the different boiling points, and we don't start calculating superheat until we are above the different boiling points, because we have that glide as a window in between.
So Clifton, thank you again for so much for coming in and doing this show and tell and talking about R32. But tell me a little bit, you know, one of the questions I ask every guest that comes on here, how in the world did you get into the HVAC industry?
Great question. I actually married into a business, a family-owned business that was commercial refrigeration and HVAC, and it was fascinating to me. And at that time, that was in the late 90s, and I was very active in the CFC phase out, right? And for me, it was the R12 transition. I was working on a lot of commercial refrigeration products that still had R12, and so we had, you know, we had blended refrigerants that could be used for intermediate replacements, such as like R414B, we had 407, there was a variety of different refrigerants we could use, but then we had different refrigerants going into new equipment. So I was always fascinated with refrigerants, but I never really understood why. It wasn't until later in my career that I started diving deeper into the education of it, and then when I became an educator, then I started learning about these things. I thought, wow, this is kind of interesting. Maybe we can share this in a fun way.
Sure. And so now you're with ESCO. Tell us, who is ESCO? What does ESCO do?
Yeah, ESCO is a certification body within the industry. We actually have different components within the ESCO group. We have HVAC Excellence, which is the accreditation side. We have ESCO Institute, which is very much on the curriculum and certification. So we do a lot of standards for the industry. And in that, we do a lot of training. So we try to work with our manufacturers to make sure that we're producing content that is current with industry changes, so that we have an industry that is prepared for transitions, instead of getting new equipment going, this is different than what I've worked with. How is it different? Why is it different?
So ESCO does a lot of certifications on refrigerant and handling of refrigerants. Many of the technicians that are listening to this probably have their ESCO card. I'm hoping they do.
That's a very good possibility. So we've been doing certifications, since the late 90s. We've done between all of our 608 and our low GWP, the A2L safety, as well as like our heat assessments that we'll use in high school and employment ready that we'll use in college. We've done about 2.3 million certifications since then. So a lot of people don't realize how much of an impact we've had in the industry. Out of all of the EPA 608 cards that have been introduced into the industry since around 96, we hold about 60% of all of them.
Okay. And recently, we've partnered up together.
Absolutely.
Daikin has partnered up with you, and we've worked together on a new certification course as we've rolled into A2Ls. Can you tell us a little bit about that?
Absolutely. We spent a few years working with the refrigerant transition. We actually had members of our team that spent time with the Safe Refrigerant Transition Task Force. We've spent time studying the ASHRAE standards and UL standards and developed an entire training course. Jason Abjute from our team developed a low GWP safety training that actually dives into A2Ls and A3 to introduce us into what all of these flammable and mildly flammable refrigerants look like. And then we partnered with Daikin to be able to do a training certification with Daikin to help to guide technicians into safe handling and installation practices for these new refrigerants. Not only to understand what they are chemically, but to understand how to work with them in new systems.
So today, is there anywhere where it's required to have this A2L certification?
Currently is not, and so we're kind of in a limbo period.
Yeah.
We prepared for this anticipating that the AIM Act and the Technology Transition Rule, both from the EPA, would be requiring a new training certification, especially under subsection H of the AIM Act, where it's talking about this transition into mildly flammable refrigerants that would potentially require a new training and certification. So as an industry, we haven't adopted a requirement for that, but we have a lot of local jurisdictions as well as state agencies that are looking at requiring it for like your mechanical license. So it's right now we're doing as many A2L certifications as we are 608.
Okay. And do you have an idea or anticipate when or if this may become actually requirement for contractors?
That is a really good one. So we actually had a request from the EPA for industry input on what we would want and what we would like to see and how it would be managed for a required training for the safe handling of these flammable refrigerants. That came out of that AIM Act. And so that was open for industry input up until the end of December. And so now the EPA is in that time frame where they're evaluating, and there is no final rule on that. So like all federal agencies, we're kind of waiting to see if and when that happens. And so many states, many organizations have just taken upon themselves to go ahead and start requiring that. We've had contractors that have called us going, we really need to make sure that our technicians are handling this because there are different controls in many aspects of it. On equipment, typically that has around 4 pounds and above of an A2L refrigerant requires mitigation controls, so refrigerant detection sensors and mitigation. But there are systems that don't require that. So understanding when that is to be applied, that is something that technicians really need to know. And then we've definitely had states that are reaching out going, you know what, this really isn't covered under EPA 608 because the 608 was for our ozone depleting refrigerants and their substitutes. And this is a whole different generation of refrigerants that would truly require a separate certification, and that's where we anticipate seeing something eventually, but if it doesn't, the industry has already taken it upon themselves to be prepared for it because the equipment's already hit the street.
Well, and I'm just putting on my contractor hat. You are on the contractor side as well. When I was in contracting, I was always looking for things where I could talk to the homeowner that maybe gave me that little bit of an edge over my competitor. And so I do think that more and more information is being shared as far as the fact we're going to low GWP refrigerants. There may be some questions homeowners have about it's an A2L. And so being able to say, yes, all of our technicians are A2L certified brings peace of mind to the homeowner, where if your competitor doesn't have that certification, that can give you just that little bit of an edge that you're looking for when you're in the customer's home, talking to them about their options and what they have available to them.
If we think back when you and I were technicians, we were successful because we built relationships with our customers. And so if you think about a new product coming into your home, think about it from a consumer. Like, these boxes have flammable gas stickers on them. The indoor units have flammable stickers on them. The outdoor units have flammable stickers. If you're a contractor that is unpackaging this box and the homeowner says, "What's that flammable gas sticker about?" and you don't know, you're going to immediately lose some of that relationship that you could have had with that customer, versus a technician that is already trained and certified. They go, "Let me tell you about this transition we're going through. It's actually a very safe refrigerant.
Yes.
And it really looks more like an A1 refrigerant that we're used to, but there's this very, very slight flammable factor, and I've been through a training and certification. I know how to properly install this, and I can tell you anything you want to know. What would you like to know?" Now you're building that relationship with the customer. And I truly believe that a trained and certified technician will bridge that gap between one that is not trained and certified.
Well, they just have confidence.
You bet.
They know the talking points versus, kind of being stuck. And that's every technician's worst nightmare.
You bet.
Customer asks a question and they don't know how to respond. And they want to be able to give a factual, correct answer. And so that's where training is so important.
It is.
So what exciting things other than refrigerants right now is ESCO working on?
Oh, wow. It's almost endless. Preparing for the next generations of equipment.
Yes.
And refrigerants, in the future, looking forward, going to, manufacturers. Like, I just came back from the Daikin facility, looking at where our equipment is going to, making sure that we are partnering with training, that we're making content available to the entire industry. Even our low GWP safety training is available for Daikin dealers on Daikin University, right? We got manufacturers that are really stepping into the training and going, "You know what? Everyone needs to be prepared. Let's do that." And so we're mainly looking at how we can give back to the industry, how we can make sure to get training and certification available to everyone, and then also looking forward, going, what's next? We need to be prepared for whatever is next, because we're already seeing things like A3, highly flammable refrigerants moving into refrigeration products. And we have to be realistic to know that even after this change in refrigerants, there will be more changes. This is not the first refrigerant change. This is not the first refrigerant change we went through. There will probably be more. And what do they look like? Because it takes years to prepare for proper training for when these new products come out.
Clifton, I really appreciate you coming out here. Do you have any final thoughts or words of wisdom that you want to share with our audience?
I think we've really said it.
Okay.
Training and certification is going to be the success for all contractors and technicians. And I encourage everyone to dive into the Daikin training side, because there's everything that you need. Daikin provides all the tools for training and success, and just encourage you to spend time investing in yourself, whether you're a contractor, you're a technician, whether you're at a distributor, or whether you are the instructor in the classroom. We are all at a transition in our industry, and we all need to be educated and prepared for it.
Well, thank you again for coming here. I hope to have you on a future episode, and looking forward to also joining you on some of your podcasts in the future as well.
I would absolutely love that. Thank you so much for being here in front of our beautiful R718 background.
For all of you that are out there, if you liked this episode, please go ahead, hit that like button. Also make sure that you hit subscribe and follow so that you can be informed of all of our upcoming episodes that we have. And until next time.
It's actually a very safe refrigerant.
Daikin wants to be involved in the community.
Making another touch point to build my brand.
So the first question we ask everyone is,